Hey there guys, so in this video I'm going to go over sample question 2 from the Society of Actuaries ExamP list of sample questions they have up. Okay, so the question states, the probability that a visit to a primary care physician's office results in neither lab work nor a referral to a specialist is 35%. Of those coming to the primary care physician's office, PCP's office, 30% are referred to specialists and 40% require lab work. We're asked to calculate the probability that a visit to a PCP's office results in both lab work and a referral to a specialist. Okay, so two ways you can really handle problems, either kind of visually, right, by drawing a diagram, whether that be a graph or a Venn diagram or something, or algebraically. Now, I'm going to kind of start out the drawing Venn diagrams, but for this question, I do prefer an algebraic approach. So I'm going to show that method as well. So first off, I'm going to list the information it gives me to the side. So the probability that a visit to a PCP's office results in neither lab work nor a referral is 35%. That means the probability of neither lab work, I'm going to use L to represent lab work, nor a referral. So you did not get referred either. So it's going to be R prime or R complement. That's equal to 0.35. And then it says, of those coming to the office, 30% are referred to a specialist. So the probability of even being referred is 0.3. And 40% require lab work. So the probability of L is 0.4. And what we're looking for is the probability that somebody requires lab work and they need to be referred to a specialist. All right. Now, drawing that out, you have a few options. So here's my Venn diagram. Here's everyone that essentially comes up into the office. This represents my whole sample space. And you either get lab work or you get referred. This is too small a Venn diagram, but should be fine. Now, the probability that you get neither lab work or a referral is 35%. So that 0.35 goes out here. Now, this whole thing should be 0.3. So that includes this section and this section. And lab work is 0.4, this section and this intersection, right? But we're not sure what exactly is what because we actually don't know the intersection. We don't know the exact number that's in the intersection, and therefore we don't know the exact number in here, which is where, doing this algebraically kind of helps. So you should be familiar with this particular formula. The probability of L union R is equal to the probability of L plus the probability of R minus the probability of L complement R. Okay, very basic formula. This eventually will become second nature, just ingrained in your mind. Now, we know probability of L and probability of R. And we're given probability of L complement intersection R complement, right? But we don't have the probability of L union R or L intersection R. We need one of them. I mean, we're going to need this one, right? Because this is what we're looking for here. So how do we go about getting it? This is where something called De Morgan's Law comes in. Okay. The exact opposite of this statement, right? Let me first quickly explain De Morgan's Law. De Morgan's Law states that say you have an intersection of two sets that you want to negate, right? Say A intersection B, and you're negating it. right, doing a complement of it, that is equal to the negation of A, the complement of A, union complement of B. Okay. Another thing that we need to know is that, say we have some event A, the probability of event A plus the probability of event A complement is equal to 1. And what that's saying is basically everything in A and everything not in A should be our entire sample space. So therefore, in this case, I'll write it to the side here, the probability of L complement intersection R complement plus the probability of kind of the complement of that, so L intersection R, right? And then a complement on the outside, that should all be equal to 1. Now here's the thing, if I want to open this up, I use De Morgan's law. So 1 is equal to, and you know what? I already have this given to me. So I'm going to just do a substitution for that. So this should be 0.35. Well, this, once it opens up, should be the probability of L union R. Okay? And to get this, all I do is simply subtract to both sides, and I get 0.65 is equal to probability of L union R. And now I have everything I need to find my final answer. 0.65 is equal to, right, 0.65 I got from here, is equal to probability of L, right, lab work, that's 0.4, plus the probability of a referral, which is 0.3, minus the thing we're looking for, the probability that you have lab work and are referred to a specialist. Now, these sum up to become 0.7. I subtract 0.7 to both sides, and I end up with negative 0.05 equal to negative probability of L intersection R. And I multiply negative 1 to both sides, and I get my final answer as 0.05 equals the probability that you have lab work done and are referred to a specialist. And that lines up with answer choice A. Okay, so the main beats of this problem, you were required to know De Morgan's law if you preferred not to do it graphically, right, or visually. And you were kind of required to know that an event plus the complement to the event takes up the whole sample space. Those two rules would get you through this whole problem. All right. If there are any other questions, throw it down in the comments. I'll answer them to the best of my abilities. If this video helped you out, hit the like button, because that definitely helps me out. But other than that, good luck, guys.